Hello guys, my name is Balkrishna Srivastava and welcome to Code with PK. So in this video, we write a Java code to define an integer array list class to store a list of integers, and we use arrays as the underlying data structure to store integers. So before we begin, it is a request to please subscribe to my channel, because out of 100 viewers, only 3 to 5 are subscribed. More than 95% of my audience is not subscribed, and a subscription is very important. So please do subscribe to my channel. So let's begin. So we have to write a Java code to define an integer array list class to store a list of integers. The class should be able to replicate the behavior of a list of integers, and we will be using arrays, single dimensional arrays, as the underlying data structure to store integers. So in this video, we implement these constructors and these functions, and in the next video, we implement these functions. Okay, so let's look at the behavior of the list first, what we expect, and then we see how we implement this. So if I take this as my list, empty square brackets to represent an empty list. Okay, I say I have to add an integer 10. So now this list becomes 10. If I say add 20, so 20 goes after 10 and the list is now 10 and 20. If I say add 30, list now becomes 10, 20, 30. Okay, 30 was added after 20, so list becomes 10, 20, 30. Okay, size 0, size 1, size 2, size 3. I can add multiple values at the same time. I can say add 40, 50, 60. Okay, so in this very order, these values should be added at the end of the list. So the list was 10, 20, 30. 40 is added, 50 is added, 60 is added. So now list becomes this with size 6. Okay, that is what your basic add should do. Alright, add an integer to the end of the list, and this add all will replicate this feature. Okay, when you are trying to add more than one integers at once to the end of the list. Okay, this triple dot means you can pass variable number of arguments here, so I can pass more than one integers here. Okay, then I should be able to update a value at a given index in the list. That is, if my indices are 0, 1, 2, 3, 4, 5, I say add 70 at index 2. Okay, index 2 has 30, I want 70 here. So my list should become now 10, 20, 70, 40, 50, 60. Okay, size remains 6, the same, but at index 2, okay, I have the value 70 which I wanted to add. Okay, and this is the behavior we expect from this second add function. The third get function takes an integer index and returns the value at that index. So if I say get 0 here, I should get 10. If I say get 1 here, I should get 20. Get 0 should again give me 10. Get 2 should give me 30. Get 1 should give me 20. Get 0 should give me 10. And similarly, get here, okay, at index 3 should give me 40. Get here at index 2 should give me 70. Okay, and if we try to get a value from an index which does not exist, this is an empty list, there is no index 0 here, there should be an exception thrown. Okay, so you have to make sure you check the index that is passed to get the value. Okay, then we have size that simply returns the size of the list. Then we have an isEmpty function that basically checks if the list is empty or not. So the return type of this function is going to be a boolean value. If the list is empty, the return value is true. If the list is not empty, return value is false. Contains takes an integer, returns true if the list contains that integer, otherwise it returns false. So contains 20 will return true, contains 20 will return false for this list, contains 30 will return true for this list, contains 30 will return false for this list. Okay, we'll keep on testing the functions as we add them. Okay, then we have an indexOf function that takes an integer and returns the minimum index where this integer is found in the list. If the integer is not found in the list, it returns -1. Very similar to indexOf in a string class function. Okay, similarly, we have lastIndexOf that returns the maximum index of this integer in the list. If the integer is not found, you return -1. Then we have a toString function to represent the list as a string, and we print the list in very this fashion. Okay, we use square brackets and we add elements inside space separated. Okay, then we have addAll int triple dot which we just saw, add 30, 40, 50, 60, very variable number of integer arguments. Then addAll a collection of type integer. Okay, so this collection is a class in java.util collection. Okay, root interface in the collection hierarchy. You should be able to write code to add all the values from this collection into this list. We'll see how. So we understand the behavior we expect from our class. Now let's see how we code this. Okay, so we have to use arrays, okay, as underlying data structure to store integers. And the thing with arrays is they are of fixed size. For example, if I create an array of size 4, okay, it has indices 0, 1, 2, 3. I have values say 10, 20, 30 and 40. Okay, if I want to say add one more value 50 to this, I cannot, because I cannot create or add a location in an array that has already been allocated. This is an array of size 4 and it will remain an array of size 4. We cannot add or remove a location. Okay, so if you want to add 50 to this array, the variable pointing to this array, okay, that stores this array, points to a location of 4 values. Okay, you now make this point this to a location containing 5 values 0, 1, 2, 3, 4 and contains values 10, 20, 30, 40. Copy from the original array and add 50. And when ARR points to this, ARR loses the reference to this and this is corrected by the garbage collector. Okay, and this is what we basically do in resize, and I've already uploaded a video separately on how to resize an array, and that is the idea that we take here. Okay, so in this case we are just simply increasing the size by 1 to accommodate 50. Okay, usually what happens, we double the size of the original array. For example, if I take the same example 10, 20, 30 and 40. Okay, 0, 1, 2, 3, size is 4. Okay, say suppose I want to add 50 again. I will increase the size not by 1, but I'll double the size. So my new array will have the size of 8, double the size. So 1, 2, 3, 4, 5, 6, 7 and 8. This is 1, 2, 3, 4, 5, 6 and 7. Okay, copy the values from the original array, insert 50, and I still have 3 extra locations for 3 extra additions. Okay, so if my ARR was pointing to this, ARR now points to this, and this is lost, corrected by the garbage collector. This is how we resize our array, and we resize the array to double its size. Alright, so when we are using the default constructor where we are not provided the size, in the parameterized constructor we are provided the initial size of the array. In the default constructor, when we are not provided with the size of the array, the default capacity is 1. Okay, it has capacity. We use a variable capacity to store the capacity of the array 1. Okay, and then when this is full, we double the size, it becomes capacity becomes 2. When this is full, we double the size, capacity becomes 4. Similarly, capacity when this becomes full becomes 8, 16, 32 and so on. It keeps on increasing as we need more space. Okay, so this is the capacity, that is the maximum number of values this array, underline array, can store. We also keep track of the number of elements. Okay, that is the number of locations that are used by this array. That is, for example, if you take this array 4, okay, same example 10, 20, 30, 40. Okay, index is 0, 1, 2, 3. You want to add 50. You increase the size to double. Okay, index is 0, 1, 2, 3, 4, 5, 6, 7. Copy the original values. Okay, and add 50. Okay, these 3 locations are still to be used. So capacity is 8, but number of elements, okay, number of locations that are being used are 5. 1, 2, 3, 4, 5. So we keep a track of the number of locations that have been used in the array. That is the number of elements that we have added in the list so far. Okay, so the size of the list is going to be 5 and not 8. 8 is the length of the array, which is the capacity, which is the maximum number of elements this array can store. And when number of elements reach capacity, we resize. Okay, for example, if I add 60, 70, 80, okay, added 3 values, size became 8. Size and capacity become equal, we resize. And this is all what we do in our code. So let me just start with my default constructor. I will say public. Okay, as I explained, the default capacity in the default constructor is going to be 1. So I'm going to take a constant private static final int default capacity equal to 1. Okay, the array to store the values. Okay, so private int array. Then we need a variable capacity to store the capacity, which is basically the array.length. So private int capacity. Okay, this is the length of the array. Okay, and you can choose not to have this variable because this value will always be equal to array.length. we always make sure this has to be equal to array.length. If it is not the case, we have somewhere gone wrong with the capacity. Okay, then we have private int number of elements that show the number of elements, the number of locations that we have used in the array in num elements. Okay, these are the three data members we need. So when we are creating this object using default constructor, we create array of size default capacity. Okay, set capacity to default capacity and num elements to 0. Okay, you can choose not to write this line of code. Okay, because by default num elements will be 0, but we do this explicitly so that the reader understands what we are trying to do. Number of elements to begin with in an empty list are 0. Okay, this is your default constructor. Moving on to the parameterized constructor, we have integer array list int. Okay, I'll say public, okay, int initial capacity. Okay, now you create an array of this initial capacity. You set capacity to initial capacity and number of elements to 0. So what I can do is I can copy this code. Okay, your capacity is initial capacity, create an array of initial capacity. Okay, number of elements are 0. So we are in a way copying the code. So what we can do is call this second constructor with default capacity when we create an object using a default constructor. Okay, calling the parameterized constructor with default capacity, which will be our initial capacity if you create an object using this constructor. Okay, so our constructors are done. Okay, then we add this resize function to resize the array. So I will say this is going to be a private helper function, private int resize. Okay, so let me explain in short how do we resize. So the idea is when capacity equal to number of elements, we resize. Okay, because when this array is full, your number of elements here in this case is going to be 4 and capacity is also 4. Okay, so when capacity number of elements become equal, you resize to double the size. Length of this array was 4, becomes length of the array becomes 8. Okay, how we do this is basically if your ARR, okay, which is array in this case, is pointing to this 4 location array. Okay, and this is 0, 1, 2, 3, some values inside. Okay, you have to double the size, so you create a temp array, okay, of double the size. Okay, and this is 0, 1, 2, 3, 4, 5, 6, 7, and this is 0, 1, 2, 3, 4, 5, 6, 7. Okay, you copy all the values. So if the values was 10, 20, 30, 40, you copy all the values 10, 20, 30, 40. Okay, keeping the indices same. Okay, index 0 had 10, index 0 has 10, index 1 had 20, index 1 has 20, index 2 had 30, index 3 has 30, index 4 has 40, index 4 has 40. And then you make this array point to this temp. Okay, so array is not pointing to this original 4 location array anymore. Array is pointing to this temp array, so this array is resized. Okay, how we do this in code is basically we create a temp array of size twice into the capacity. Okay, and we have to also update the capacity. I'll change capacity, okay, into equal to 2. Okay, and then copy all elements from array to temp for int I equal to 0. How many elements we copy is number of elements. Okay, we say temp of I equal to array of I. Okay, we update the capacity. Okay, and we return temp. Okay, so when resize is called on array, a new array is returned temp of double the size of the array. Okay, and all the elements from the array copied into this temp array. Okay, so now I can write my add function. Okay, add int. So I'll say public void add int x. Okay, so I resize if capacity equal to num elements. Okay, I can simply say array is resize. Okay, so this function takes care of creating a new array of double the size, copying all the elements from the original array to temp, updating the capacity as well. And when you return temp, array which was pointing to the previous array now is pointing to this resized array temp, which is double the size. Then add element x at the next available location. So you say array next available location is going to be num elements x and num elements plus plus. Okay, what do I mean by this is if you start with a default capacity of 1 as index 0, num elements is 0. Okay, let me take NE for short. Okay, num elements is 0, capacity is 1. Okay, so the next element that you add, suppose it gets, say, let's take a different value 7, number of elements are 0, so you add 7 at this index which is 0, so this array now becomes at index 7, index 0 you have 7. Number of elements is increased by 1, so number of elements is now 1, capacity is also 1. So the next value, say 18 is being added. Okay, we resize to double the size, so we get an array where first location index 0 has 7, the original value, index 1 is available for the next value, so you add the next value here at this index any, and number of elements now become 2, capacity is now 2. Okay, and when the next value is supposed to be added, say 23, you resize again to twice the size, so 7 and 18 from the original array remain the same, indices 2 and 3 are available. Okay, number of elements were 2 and capacity is 2 after resize, so 23 is added at a next index which is NE, which is 2, so 23 is added here, NE plus plus, number of elements plus plus, number of elements is now 3. So when you add the next value, say 87 goes at this index number of elements, adding the value at this index number of elements, so 87 goes here, number of elements now becomes 4, all of 4 locations are being used, capacity 4, capacity and number of elements are equal now, so for next add resize will happen again and the process continues. Okay, that is what this code does. Okay, if the capacity and number of elements are equal, you resize, you add the new value at the next available index which is num elements and increment the number of elements by 1. Okay, so the next function that we need is add intent. Okay, that is add an integer at this given index, update the value at the given index. But before that, let's just code this toString function so that we can see the values that we are adding. So I can say public string to string. Okay, and I want to print my array like this within square brackets, value space separated. So I'm going to say string s is square brackets, okay, s plus equal to space closing brackets, return s. Okay, you can use a string builder and optimize this, but I just want a functional toString for now, so I'm going to stay with strings. I'm going to say for int I equal to 0, the number of elements are num elements. Okay, all right, I say s plus equal to array of I plus a space. All right, so in my test integer array list, I am going to say create an empty list. So integer array list, list 1 is new integer array list. Okay, not providing it any default capacity, so default capacity will start with 1. I am going to say sys out list 1 equal to plus list 1. Okay, this will call the toString function. So for an empty list we get this, which is what we want. So okay, I'll say add 10 sys out. Okay, add 10. I'll say list 1 dot add 10 and then I print. Okay, so add 10 and it becomes this. Okay, so I can get rid of this. Okay, and then if I print, yep. All right, I can add a few more values, 20, 30, 40, say add 20, 30, 40, 20, okay, 30 and 40. Okay, and then if I print again, okay, when you add 20, 30, 40, it becomes something like this. All right, so our add is working and we are able to resize the array as well. All right, so if you want, we can code this function to get the size of the array. So I can say public int size, which is basically the number of elements. Okay, and when we are printing this, we can add the size. I can say size equal to, okay, plus size. Okay, so size is 0, size is 1, size is 4. All right, and we can also print the capacity. Okay, just for testing purposes. All right, if I run this, So when you have an empty list, size is 0, capacity is 1. When you add the first value, size is 1, capacity is also 1. When you added 3 more values, size is 4, capacity is 4. When I add one more value, okay, say if I add 50, okay, add 50, okay. So when you add 50, oh, I did not print again, and you print, so size is 5 because we have 5 elements, but capacity is 8 because we are doubling the capacity once we are resizing. Okay, so whatever we discussed and we coded is working fine. Okay, I'll leave the capacity on for now and size on for now, and I'll remove this later. Okay, so basically you should simply be doing this, simply be doing this. Okay, but I'll comment this out for now, and we'll be using this to print the size and capacity both. Okay, now add is working, size is working, toString is working. We move on to add int. So I'm going to say public void add int x at this particular index. Okay, all right. So taking an example of this, I have my list as 7 18 23 87 0 1 2 3. Okay, valid is number of elements are 4, capacity is 4. If I want to add, say add 70 at index 2, that is I want to update the value. I don't want to insert. Insert will come in the next part. So I have an insert method in the next part, right? Add 70 at 2, it means update the value at index 2 to 70. So this should become 70, and that's what we want. Okay, this is easy, but we also have to validate, okay, the index. Okay, index has to be valid. If index is -1, it is invalid. If it is any value less than 0, it is invalid. So the first thing we can say is, okay, if index is less than 0, okay, I can throw new illegal argument exception, and I can say invalid index, and I can pass the index. Okay, and this function throws illegal argument exception. Okay, then if the index is less than the number of elements, that is if index is less than num elements, right, that is it is one of these indices in the list. Okay, so if the list is say 28 7 3 4 11 18, okay, indices are 0 1 2 3 4 5, number of elements are 6 in this case. So valid index right now is anything less than number of elements. Okay, if this is the case, we simply update the value. We say array, okay, of index is the new updated value, and we return. Okay, else comes the part where index is greater than equal to number of elements. And there are two ways where you can define this behavior. What do I mean by this is, for example, if I now say add, I have this list now 7 18, okay, after adding index 78 index to have 70 and 87, okay, number of elements are 4, size capacity is 4. Okay, if I say add 100 at index 5, now 5 is greater than equal to number of elements. Now if it is equal to number of elements, the functionality is the same as add. Okay, that you are adding a value at the next possible index, next available index, which is index 4 in this case. Okay, and which will be index 6 in this case. Okay, next available index is 6. So we can have one more case. Okay, if index is equal to num elements, okay, we simply say add x and we return. All right, okay, that is you want to add the value at the next available index. The final case is, okay, so we had the case for equal to. The final case is when index is just greater than number of elements, and this has two possible cases. This has two possible cases. How? If I try to add at index 5, now 5 is greater than number of elements, which is 4. Next available index was 4, 5 is even after that. Okay, so 5 is somewhere after the next available index. So you can simply say, okay, my next available index is 4. So if you pass any value greater than next available index, which is next elements, I will add the value here itself. I simply do add x, okay, for all the index values greater than number of elements, okay, for less than 0, for less than number of elements, for equal to number of elements, and for greater than number of elements. That is, you have first choice, okay. Second choice, this is your first choice. Second choice is going to be at the very given index the user wants to place the value. That is, if I want to add 100 at index 5, my list should become 7, 18, 70, 87, index 0, 1, 2, 3, index 4, index 5. So index 5 should have 100, okay, and the indices which was skipped, which includes 4, should have 0, okay. So to this, if I want to say add 120 at index say 9, okay, so indices are 7, 18, 70, 87, 0, 1, 2, 3. You have to add the value of index 9. So 4, 5, 6, 7, 8, 9, okay. You add 120 here, all the others are zeros, okay. Now number of elements in this case becomes 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All these values are zeros, okay. This is a part of the list now, okay. Number of values in this case becomes, number of elements in this case becomes 6, and the array has to resize accordingly, okay. So the second option is, okay, place the new value at the required index, okay, and we have to show that this index is valid, okay, because for this list index 5 is going to be invalid. This will give you array index of bounds exceptions, because capacity is 4 and number of valid indices are 0, 1, 2, 3, okay. So what we do is, while my index is not within the capacity, okay, I will resize. I will say array is resize. I keep on resizing, so every resize will double the size. So in this case I had 4 elements, so 4, it becomes 8 elements, 1, 2, 3, 4, 5, 6, 7, 8, okay. My index still is 9 and valid indices are till 7 only right now. When size becomes from 4 to 8, so size goes to 8 to 16, okay, and then 9 becomes a valid index. So resize will happen twice in this case. And then I say array at this particular index is going to be this value x, and my number of elements is now index plus 1. So the next available index where you should be adding the values index plus 1. All these indices in between go to 0, okay. So let me just comment this and test this simply adding this, okay. So if I want to say let me just print, let's see what we have, okay. All right, okay, size is 5, capacity is 8, okay. I say add 70 at index 2, okay. One dot add 70 at index 2, okay. 70 first and that index 2, right, okay. And then I print. So when you add 70 at index 2, you have 70. Let me add at an invalid index. I should get an exception. I say say -2 gives me an exception, okay. So I comment this out, okay. The next available index now is, size is 5, so the next available index is 5. So if I do add say 80 at 5, it should be okay, okay. Add 80 at 5, 80 at 5 and print, okay. 80 at index 5 is okay, size is now 6, capacity remains the same, okay. 80 was added. So next testing my behavior is when my index to be added is greater than number of elements, right. So for this, if I choose say index say 10, all right. So if I say add 100, or we choose the index that we discussed, okay, index 9, at 100 at index 9, okay. List 1 dot add 100 at index 9, okay, okay. So you will see the new value is added right after the last element, Okay, because that is what we are doing. Okay, for all index values greater than the number of elements, index value 9 greater than number of elements, which is 6. All right, we simply add it at the end of the list. If we take this other idea where we resize as long as the index does not become valid, you see when I add 100 at index 9, all the remaining indices between 6 to 9 are zeros. Index 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, and size is now 10. Capacity reached to 16 because 16 capacity was needed to accommodate 9 as a valid index. Okay, so we can do this testing once more. We can say system.out.println add 100 at index, say I'll make it 18. Okay, I'll make it 200. 200 at 18, 200 at 18, list 1, 200 at 18. So index 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, size is 19 now. Capacity had to be 32 to accommodate 19. Okay, so I will comment this out. We'll stick with our first option. Okay, giving you the second option in case the requirements require that. So when you add an index 9, it simply adds at the end. When you add an index 18, simply adds at the end. Size increases by 1 only. Capacity remains the same. All right. So next we have is we have get. So simply write a method to get the value at this index. So I'll say public int get int index. Okay. And since it is taking an index, it will also throw an illegal argument exception. My valid indices are going to be 0 to less than number of elements. So if index is less than 0 or greater than equal to number of elements, I'll say invalid index or index, okay. Else I simply return the value at that index in this array. Okay, so I can add some gets in the between. I can say system.out.println list1 get says 0 equal to list1.get 0. Okay, list1.get 0 is 10. Okay, I can copy, I can paste it here. Where did we update the value? Oh, we update 70 at index 2 here, right? So I can say list1.get at index 2. Okay, list1 at index 2 is 30. Okay, then I will do this after I update index 2 to 70. So 30, then I updated index 2 to 70. Okay, then get 2 is 70. Okay, now if I do any invalid index, okay, I say list1.size, list1.size. Okay, I'll say size. This will give me an exception. Okay, because I cannot get the element at this particular index. All right, next is empty, right? So isEmpty can simply use size public boolean is empty. Okay, return size equal to 0. Okay, so I can say sysout is list1 empty. Okay, I use a ternary operator, list1 dot empty question mark, yes for return value true, no for return value false. Okay, so list1 empty, yes, size is 0. Then we can add somewhere in between, list1 is empty, no, because this is the list. Okay, should add after the list is printed. Okay, then again after the list is printed, I can say again list1 is empty, no. Okay, all right, then we have contains. So I will write a method public boolean contains int x. So this method will return true if this integer is found in this list, otherwise it will return false. So all I have to do is iterate the array iterate the number of elements and look for this integer. If this integer is found, return true, otherwise return false. For int I equal to 0, I less than num elements, I plus plus. If my ith integer in this array equal to x, we return true. Finally, we return false. Okay, int I is double equal to. Okay, so I'm going to say list1 contains 10. I'll say dot contains 10. Okay, contains 10 is false because list is empty. Then we added 10. Okay, list1 contains 10 is now true. This one, sorry. Then again, after I print the list, I say list1 contains 10. Here, true. Then I can do list1 contains 50. Okay, list1 contains 50 is true. Did we add 50? Oh, contains 50. I have to pass 50. Sorry, my bad. List1 contains 50 is false. Then list1 contains 50 after you add 50 is true. Okay, list1 contains 70 when you have not added 70 is going to be false. Okay, then list1 contains 70 after you add 70 is going to be true. Okay, so contains works fine as well. All right, next is indexOf. So indexOf basically returns the minimum index if of this integer where it is in the list. Okay, there can be multiple occurrences of this integer in the list. You have to return the minimum index for indexOf. So we say public int index of int x. Again, since you have to find the minimum index where this integer is found in the list, you have to iterate this array from left to right. If the value at any index equal to x, you return that index. So basically you do the same thing. You return I, finally you return -1. Okay, since these two codes are same, I can use the return value from indexOf to code contains. I can say return indexOf x is not equal to -1. There is some valid index where x is present in the array, so indexOf should not return -1. Okay, now if I run this, my all contains is correct. Contains, okay, then contains 10 true, contains 50 false, contains 10 true, contains 10 false. Okay, so if you want, you can print indices of. Okay, so I can this is out index of 10 in list1 equal to list1 dot index of 10. Okay, so it will say index of 10 is, I'll say 20 and 30, 20 and 30. We don't have 30, right? So 30 should give us -1. 30 should give us -1. 20 at index 1. We can try for 200 and 300. 200 and 300. This is for 200, and we can try for 300 as well. Okay, 300 is not there. 200 is at the last index 0, 1, 2, 3, 4, 5, 6, 7. Okay, then we move on to the last index of. Okay, last index of basically does the same thing. You just have to iterate from the right end to the left end. So we say public int last index of. You start with the last index, which is number of elements -1. You go till greater than equal to 0 and you do I minus minus. Okay, so we can test last index of using the same idea. Okay, last index of last index of dot last index. Be paste. Okay, so last index of 10 is 0 because that is the only index where 10 is present. So we can add 10 again. So I can say list1 dot add, say simply 10. Okay, and I print the list again. Okay, so last index should be now 8. Okay, and index should be 0. Okay, if I update some value, if I say update 80 to 200, okay, I update 80 to 200. 80 is at 0 1 2 3 4 5, okay, I update 5, okay, okay, so this 80 becomes 200 now. So index should give you 5 and last index should give you 7, okay, for 200. Okay, so this is working fine. Okay, so values which are not present should give you -1. Next is toString, which we have already done. Let's do addAll. So addAll is basically public void addAll int dot dot dot. So this means variable number of arguments, I'll say integers. Okay, this means variable number of arguments, that is I can say list1 dot add all, okay, I can say 2 integers, okay, I can say 4 integers 89 and 45, okay, I can say 7 integers, I can say 18 10 11, okay, and I can pass an array as well, new integer, okay, with values 2 3 4. All of these are possible because we have this. Now let's implement this. So what we have to do is you can iterate this integers using a for each loop very simply, okay, and simply call add. So basically adding all integers that were passed to this list, simple as that. Okay, let's just now print. Okay, so we are adding a lot of integers, so let's see. So when you added 7 11, when you added 7 11 18 19 45, when you added 6 more, okay, and then when you added 2 3 4, okay, so you can add 2 integers for any number of variable number of arguments of variable number of integers, okay, or an array that contains an integer, because this is treated as an array. Okay, this argument means variable number of integers, but you can treat this as an array. Okay, if you want you can print the length, so you can say integers dot length. Okay, so you see integers is an array here. Okay, so you will get 2 because we are passing 2 integers, then 4, then 7, and then 3. Okay, all right, next part is adding a collection. The last function is, so basically any class that implements a collection of integers, we should be able to add all integers of that element. What I mean is, if I have a collection type integer, I'll say C. Okay, this also means the same if I rename this at integers. Okay, same thing, I'm able to iterate all the integers in this collection, so I can use a for each loop on this collection of integers and add each of them one by one. Okay, so if you want to test this, okay, so let me see what is the last we have. That's a lot of elements added, right? Okay, so it adds 7 11 and 2 3 4, 7 11 and 2 3 4, that's okay. Okay, so if I have a collection, okay, for example collection of integers, if I have a stack of type integer, stack 1 equal to new stack, okay, and I'll say stack 1 dot add say 33, okay, and I'll add 33 35 and 12. So when I do list1 dot add all stack 1, it should add all the contents of the stack in list 1, and when I print list 1, okay, I should get these elements. Okay, so 7 11 2 3 4 were added, and 33 35 12, 33 35 12. Okay, you can use any other collection, you can use ArrayList itself. You can say ArrayList of type integer, ArrayList is equals to new, okay, and you can say al dot add say 24, al dot add say 39, okay, and you can add all these elements from this array list because it is a collection of integers. AL. Okay, so we get 24 and 39. So we get 24 and 39. Okay, and it can be any collection of integers. Okay, all right. So we'll do this testing better in our second part when we complete all the functions. So this was your Java code to create an array list, integer array list class. That is basically an array list of integers. We use arrays as the underlying data structures. In part one, we covered all these functions and these two constructors. In the next part, we see all these functions. Okay. So I hope you like this video and this was helpful. So if there is any doubt, there's a part you do not understand, please let me know in the comments. I always try to answer all your comments. You can also let me know in the comments if there's a question you want to solve or if there's concept you want to discuss. So please let me know your thoughts about this video in the comments. Please like this video, subscribe to my channel, and thank you for watching.